Good morning. You're looking at a plot of an M8BO showing low viscosity. We've had a request for a 748 piston falling into a 750 bushing. 748 pistons are very large pistons. They're 0.002 inches difference OD from the inside of a bushing. They're used when you're measuring a fraction of a centipoise in viscosity. Very, very low. We use them very rarely. This plot here is available from Norcross. It has a PDF number, and if you're an agent, you can get a copy of this. If you're a customer, you can send you a copy of this. But I'm going to do a little water demonstration here showing about a 748 piston, just so you know what you're getting if you're dealing with this. We have 3 pistons here and 1 bushing, and we have some water. This is a 735 piston. If I fill it full of water and drop it, it drops kind of fast. That's logical. 746, getting a lot bigger here. It hardly falls at all. If there was a piston rod on this, which an M8BO or M8BO normally have, you'd see it falling more quickly. It's with a 746 that we can measure the difference in viscosity between hot and cold water. Now, we go to a 748 with no water. 748 piston. Watch. Just air. Just the air resistance slows it down. If you want a 748 piston, you're working on a viscosity which is very, very low. As I said earlier when I was holding up the graph, a fraction of a centipoise. Because a 746 piston can be used for water, and what is water? It's about 1 centipoise. It actually changes from hot to cold, going as high as 1.1 when it's cold, down to about 0.6 when it's hot. So if you're using a liquid that's something like the viscosity of water, 1 centipoise, a 746 is more than adequate. You could even go to a 744, which would fall twice as fast as this. You would obviously not go to a 735 in water, because it falls so fast, there's not much sensitivity to the changing viscosity. So this is a brief video, very brief, on the issue of somebody asking for a 748 piston. You got to really know what the viscosity is if you want to go play with a 748 piston, because you have natural resistance to the air, and if you put a fluid in there, you can see air bubbles right there from the water coming out. If you put fluid in there, you're going to have more resistance, and you'll have a time of fall so long that it exceeds our normal 20-second limit. And remember, you always want the time of fall to be between 3 and 9 seconds. That's the ideal. It's not scientifically hard set, it's just a generic good time. Even with a thin viscosity fluid, if you're falling in 5 seconds, we know from 70 years of experience we can measure small changes in viscosity that are more than adequate for needle coating and stent coating and other medical coatings that are typically very low viscosity. So that's a little talk on the 748 piston. Have a good day.